Alright guys, welcome to this page of the notes, and let's go ahead and do another subtracting rational expressions again, where the rational expressions have polynomials in them. So what I would do is start by going ahead and factoring these if we can, to find our LCM and make that LCM our common denominator. Alright, so here we go. I have 3x squared plus 8x plus 5. I need to factor that guy. Well, we saw this just a minute ago in a previous video on a previous page of the notes, and here it is again. This is a general trinomial, but this is a general trinomial where the leading coefficient is not a 1. I think the easiest way to do these is a method known as slide and divide. So what I would do is I would slide this guy over. You wind up with x squared plus 8x plus 15. Factor that. Well, to get 15, I need 5 and 3, and 5 and 3 also get me 8. So plus 5 plus 3. But the method is called slide and divide. Please do not forget to divide by the original leading coefficient. And then simplify. Well, I can't divide 5 by 3. They're not evenly divisible. So the 3 just gets thrown up in front. 3x plus 5. And 3 divided by 3 is 1, so x plus 1. So this guy will factor into these two binomials. 12x plus 20. Sorry. Well, I believe I can pull a, what can I pull out there? I can pull a 4 out of those guys. So I pull out a 4, that leaves me with 3x plus, ooh, look at that, 3x plus 5. All right, so my LCM is going to be equal to, I need the 4, I need the x plus 1, and I need the 3x plus 5. All right, so there's my LCM. All right, let's go ahead and redo this guy, getting my least common denominator. So I have x minus 1, right? That's my numerator. My denominator factored is going to be a 3x plus 5 times x plus 1. All right, what do I need? What do I need in order to turn this into the LCM? Yeah, all I need is the 4. And you think, hold on, here we go again. I'm just multiplying top and bottom by a constant. Hang on a second. X minus 1 over, this guy is a 4 times 3x plus 5. What do I need to get the top, or to get the denominator to be my LCM? I got to multiply top and bottom by an x plus 1. I got to multiply by that quantity. So this one, we're not multiplying both of them by constants. Little trick here. All right, here we go. I found my LCM. I'm going to make that LCM my least common denominator. So again, I'll need to distribute the 4 through the x plus 1. Careful over here, right? Binomial times a binomial, you'll need to FOIL those guys. All right, so that's going to give me 4x minus 4 all over 4x plus 1 times 3x plus 5 minus, FOIL this guy out, x times x is x squared. X times 1 is x. Negative 1 times x is a negative x. Plus x minus x cancel each other out. Negative 1 times 1 is a minus 1. So there we go, minus 1. Put it in parentheses. I'll put that one in parentheses too. Why not? Doesn't hurt. 4x plus 1, 3x plus 5. All right, so I've got my common denominator. I can go ahead and subtract the numerators. Again, the reason I threw that in parentheses is just to help me remember that this minus sign, whenever you're subtracting rational expressions, if you've got a quantity here, you'll have to remember to distribute that through the quantity. And the parentheses generally help us remember to do that. Okay, so I wind up with 4x minus 4 minus x squared plus 1 all over 4x plus 1, 3x plus 5. One last step, combine like terms. Negative x squared plus 4x, negative 4 plus 1, well, that's a minus 3. all over 4x plus 1 and 3x plus 5. Again, in this case, not quite as nice an answer. However, most of the time you do these will be the kinds of answers that you get. The previous two example problems where we wound up with a GCF that showed up when simplifying and it just simplified down to a number, those are much, much more rare. They don't show up that often. I just wanted you to see them in case you do see it in the homework or on a quiz or a test or something like that. But most of the time, they're going to go more like this. We're going to wind up with an answer that I agree, it's not quite as pretty as just getting a number, but more often than not is what you're going to wind up with. All right, guys, head on over to the next page of the notes. We're going to do sort of the same thing, but now it's going to be with complex rational expressions, which you should remember from the previous section, and how we're going to deal with those complex rational expressions. Can't wait to show you how it works. Head on over to the next page of the notes, and I'll meet you guys there.